Okay, we're going to use technology to support simulation, and it's going to show variations in confidence intervals. Our learning goal, you can see, we're going to use simulation to illustrate variations in confidence intervals between samples and to show that most, but not all, confident intervals contain the population proportion parameter that we're looking for. Okay, so the idea of this is centered around this activity here, alright, and we toss a fair coin. It's fair. We're going to toss it 20 times. We're going to determine the proportion of heads observed in this sample, and suppose this is repeated 10 times. Okay, let's say it's 10 times in total. Okay, so we're going to generate 10 values of the sample proportion p hat of heads in 20 coin tosses. Then we're going to use the calculator to find an approximate 90% confidence interval for all of those sample proportions. And then we're going to check how many of these did contain a population parameter. Was it 9 out of 10, 90%? How many of these would you expect? Well, look, let's answer the firstly, let's answer the last question. Alright, how many of these would you expect to contain? Well, with a 90% confidence interval, by definition, we would expect 90% of such samples to contain the population proportion parameter there. So we would expect 9 of the 10 intervals. Okay, so let's see. To go back to part A, we need to determine a few things. We need to determine what our value for the population proportion is, and it's a fair coin, so it's going to be p is 0.5. We are looking at a sample size, or a number of trials in this case. N is 20. We've got 10 samples of that. Okay, so that's something that we need to bear in mind when we enter it in the graphics calculator. So let's do that. Because this is a binomial situation, heads and tails, we need to go into our probability and go to random and binomial. Okay, and the syntax is n first, so that's 10 p, which is 0.5, and the number of samples we're doing, so which is 20. Okay. Oh no, I've got it around the wrong way. It is actually, sorry, 20. N is 20. P is 0.5, and there's 10 of those trials in total. And then we have to divide it by the size of the n and the sample size. Okay, so we've got 10 there. Now, I love exact values and fractions, but in this case, it's going to make things harder than necessary. So what we might do is convert all of them to decimal. So go to our catalog, tab 1, decimal, and voila, we have our values there. Now, let's check it, how far through the question we are. Yeah, indeed, we have come up with 10 values of the sample proportion p hat. There they are in all their glory. So all their values for p hat are there. So we're going to go for a confidence interval in part B for 90%, and we're going to have 10 confidence intervals there. Alright, and so let's have a look at what that looks like. First one is 0.55. So in fact, the original fraction ironically turned out to be the better bet. It was 11 out of 20. So voila, and there's our first one there. So we've got 0.37 up to 0.73. Did that contain the population parameter? Yes, it did. 0.37 up to 0.73. Yes. So I'm going to keep a tally here. There's 1. Okay. Next one. Let's do it again. We have 0.45, which you might be able to see on the screen there. P hat, which is 9 out of 20. Alright, 0.27 to 0.63. Okay, yes, that contains 0.5. There's 2 out of 2. Now continuing on in the same vein. Hey presto. That's interesting. We got 10 out of 10. So how many of these intervals? We got 10 out of 10. Okay, and we were expecting 9 out of 10. So let's go back to our learning goal now. We were to see variations in confidence intervals between samples. Well, the intervals varied, that's for sure. We can see variation in those intervals there. Okay, let's look from here to here, for example. We can see variations all the way through, except for when a probability repeated. From there to there, it's quite different. So, and at the top end, likewise too. Okay, so quite different or slightly different, but there is variation, absolutely. And as for the last part, that most but not all confidence intervals contain p. We could recalculate that or take larger numbers of samples, more than 10, and we could check that out a bit more. But certainly the most bit, yep. So yeah, fairly useful little activity there.